Alright, my name is Chuck Gardner. I'm a subject matter expert for NiceArc, and I put together this instructional video for a rainy day or an after-school project. If you have some basic BoeBots, I call it tethered BoeBots, kind of a throwback to some old school remote control cars. So it just takes some basic BoeBots and some real simple supplies. All I had was some phone cord, which I cut the ends off and stripped some wire back. The phone cord I had 4 cables. If you do this with some network cable, you'll get 6 or 8 carriers, and you can do a little more with it. The video is about 22 minutes long, and it's going to go through Schematic, and then it's going to show you some wiring diagrams, and then I'm going to analyze the code that I wrote, which you can customize, and then a quick demo. So here we go. Alright, we're going to take a look at the schematic for the push-button driver. This is lucidchart.com. I use this for my schematics and flowcharts. It's got a great electrical library, as well as the ability to create your own shapes and do whatever you need to do with them. So 2 BoeBots tethered across the gap here with a phone cord, 20 foot or so, 4 conductors, so we can take 3 signals and a ground. So the roller, this is the one that's on the floor, has 3 inputs. We're going to connect it to 0, 1, and 15. Go away. The driver, the one in your hands, has 3 push buttons, and those are strictly going to be connected to VDD, and then they're going to jump over to the other BoeBot. So a couple things we're going to need to grab from my library is a ground. We're going to need one on this BoeBot. We need one on this BoeBot. Dog's getting a little rambunctious. We're going to need some resistors over here. The standard push button circuit requires a 10K and a 220. So I've got those already here. We're going to control C, and 1, 2, 3. I'm going to put the 10Ks over by the ground, in line with the push buttons. You'll see why in a little bit. So I'm going to line up that blue ghost line on the middle of the push button over here. I'm going to put the 220 in line with the pin on the local BoeBot. Need a little more room here. Slide this ground over. I can slide that over, and I can bring that in right to there. All right, let's see if we can duplicate that. So 220, line it up with the other 220 on the pin, 10K, lined up with the push button, lined up with the other one, there, 220 on the pin, and 10K on the push button. All right, there. All right, now we wire it. So one side of the push button needs VDD, and oops, 3 wires, 1 to each push button. You can jump them off on the breadboard if you want. I did it again. You can jump them off on the breadboard if you want, but you're going to need 3 wires anyway. So I'm going to show it all. It's all coming from VDD. Slide that down a bit. Then the push button goes into the phone cord with the ground across, and it's going to come in to a row on your BoeBot. That's going to hit the 10K and the 220. Each push button, and this is right out of the Parallax book, on the downstream side from voltage has to hit a 10K to trickle down. We'll talk about that in just a second. And then a 220 back to the pin. Oh, this one's off a little bit. There we go. And the 220 is going to go right, oh boy, right to the pin you're using. All right. And the 10K is going to take us to ground. So this is called a drop-down resistor or trickle-down resistor. What happens is when I push this, when I make contact on this button and I got VDD flowing into this, well, hypothetically it's going to flow into the pin, right? Because 220 ohms is going to be less than 10K. So electricity is going to want to flow this way, and it's not going to want to flow this way. when I let go of that button, without this 10K here, I have the potential to keep this line as high into the pin if it's got nowhere else to go. It's just going to hang out there. So what the 10K does is it provides a method to trickle down to ground, so that voltage doesn't stay high in this pin giving a bad reading. So the 220 is dropping the 5 volts into a safe voltage for the pin to read, but the 10K is going to give it somewhere to go after it can't go through the 220 anymore. It's going to be allowed to go to ground through the 10K. And then the last thing we have to do is that 4th conductor and the phone wire, or if you're using a network cable, we just have to make a connection to ground. I'm going to slide these down a little bit so it doesn't roll over our resistor. There we go. And that's the wiring schematic for our push-button driven remote-controlled BoeBot. So this is a program called Inkscape, and it's how I do a lot of my wiring diagrams. I've got 2 BoeBots here, and we're going to talk about how we wire the push-button driver and the push-button roller. So this will be the one that you have in your hands, and this will be the one that's on the floor. So this is what we're going to do. What I've got is I've got a collection of colors and lines and wires and LEDs and resistors over here. If I need them, I'm just going to come over here, copy and paste. You probably won't see that, but when I drag stuff on, that's where it's coming from. So I'm going to zoom in, get a better view for what we're talking about here. All right. So we'll start with the push button, and this is a pretty simple setup. Again, this is just 3 push buttons, and we're going to wire straight from VDD out to the other BoeBot. So I'm going to start with a red wire, and I'm going to plug one end of it into VDD, and then I'm going to take this other end, and I'm just going to, well, let's move it over 1 row. That way we'll use this row to jump to the next push button. All right, so there's our first red wire. We're going to use it to piggyback to the next push button, and I'm going to want to bend them away. Let's do this like that. And finally, one more. And we'll put this one right there, and this one right there-ish. All right. So we've got our 3 red jumpers to our push buttons. So now we turn this BoeBot on. I've got 5 volts running through these red wires, which means the bottom half of these push buttons are hot. Notice the white dots here are designed to show you the curvature of the legs and the push buttons. The curvature should always be on the opposite the valley here. What that means is that this row is connected to this row on the bottom is connected to this row, and when we push the button, then the connection becomes this way, connecting all the pins. So right now, all we're doing with these red wires is charging the entire bottom row of each of these push-button circuits. So when we push the button, we want to be able to charge the other row, and that's the signal we're going to send to the other BoeBot. The wire I was using was a old Mabel phone cord, 4 conductors, control, oops, D, D, D. All right, we're going to make this one black. We'll make this one red. And we'll make this one, do I have a yellow? Oh, yeah, I have a yellow right there. And we'll make this one green. Good to go. Ooh, that's a tough one. Let's change that yellow a little bit. There we go. Okay. So, for continuity's sake, I'm going to bring these all to the top. Layer, raise to top. Nope. 1 second. Object, raise to top. There it is. Okay. So black wire is going to join VSS to VSS. We'll deal with that when we get to the BoeBot. I'm going to use the red to connect the first one. It doesn't matter what color you use. I'm going to use yellow to connect the second one. And don't forget, you're going to the top pin here and the top row from the push button. If you put the red wire into the other row, then you'd be doing this off the bottom row of the push button. And green for the fourth. All right, and there's our phone cord essentially going to the going to the other BoeBot. Okay, that's it. First BoeBot's wired. This is the one that you hold in your hand. 3 push buttons. What we're going to use this one for is to cut out the motion and sound the piezo speaker if you got it so equipped. And these are going to control forward, back, left, and right. Well, left, right, and back. Forward's default, and you'll see why. Okay, so here we are. Now, the push-button circuit requires some resistors, in addition to, obviously, the signals coming from the other circuit board. The resistors, I need 220s to go back to the I/O pins, and I need a 10K to go to VSS. The 10K to VSS is a drop-down or a trickle-down resistor, and that's going to take care of any spare voltage, any leftover voltage in the line, and then the 220 is just going to protect these circuits, these input pins from overcurrent. So I happen to have a couple of resistors off screen here, so I'm going to bring in a 10K. Whoops. I'm going to bring in a 10K, and I'm going to need 3. Wrong tool. There we go. Oh my God, why are you doing this to me? No. Oh. Oh! Okay, we're back. Wrong button. Okay, I got this. There's 1, there's 2, and there's 3. I need some 220s. So we're going to bring it in, and we're going to need one at pin 0, pin 1, and pin 15. Could have used 2. I just felt like 15 this morning, so no worries. All right, so we still have to connect black to ground. So let's get that out of the way. And yeah, I'm going to connect it to the first one. Whoa, whoa, whoa. Let's get that out and around there. Okay. Because I'm just, these 3 resistors, when you hook them up on your BoeBot, they're going to be over the breadboard. I'm just putting them out here for now for clarity's sake. In fact, I think I'll move them down here a little bit. Okay. So the red came from the top push button, so red is going to go into the topmost signal, which in this case is going to be pin 15. And things are going to start to get kind of crazy as they cross over each other here, so do the best job you can with your wiring, but you'll get the point here. Yellow goes into the middle push button, so yellow is going to go to the middle signal, which in this case is going to be eventually feeding the middle resistor, which is going to go to pin 1. And green, we'll just put it down here. So there's our tether coming into our BoeBot on the ground. All right, now to wire our resistors. Let's get some wires. So here's a pre-shapen wire like you get back from your students. I'm going to go ahead and drop this into pin 15, and the twist is fine. Let's make another one. Oh, so close. Object, send to back, lower. And one more. Lower. Again. Let's just bring this up. Raise the top. There we go. Okay. So the bottom resistor I'm going to connect to pin 0. Second resistor I'm going to connect to pin 1. And on the other side, I'm going to connect this to the same row that the first wire comes in on. Make a copy. Make a copy. Yeah, they're on top. Deal with it. And that goes to the third conductor, and this one goes to the second conductor. Okay. I gotta change rows because my 10Ks are gonna go there. Transfer wiring is this easy. There we go. Okay. Now we got to wire the 10K resistors, and they're going to go straight to ground. So I'm going to use that one. And that one. And that one. And that one goes there, and you go there. Okay. I need the other ends to go like it is. Doesn't matter which one goes where. Sorry about that. Whoa, come on. So I'm going to take the inner one to there. Another one, and another one. This one will go to there. And this one will go to there. And I'm probably going to have this tether come in underneath everything. You see it's crossing over the top here. I probably have it come in underneath everything so that it wouldn't mess around with these resistors, so like that. So these wires come in underneath. They're going to come right over the top of the breadboard, and you'll see in the video. And then you need 3 10Ks, 3 220s, and that's the other end of the push button circuit. Push buttons and the signal in. All right. Hope that helps. This is the code for the push button roller. The driver doesn't need any code because the push buttons are wired directly to VDD, and they're going to send the high signal across to the to this push button roller BoeBot. This is the one that's on the floor, and it's got the 220 and 10K resistors, and we're going to use pins 0, 1, and 15. This is the Parallax IDE Chrome app extension, from Parallax. It's great for doing these projects now because it's consistent from platform to platform. I'm on the Mac, but you wouldn't know it. It's the same look when you're on a PC. So again, using those pins, I'll copy and paste this code so that you can have it and copy and paste it yourself. But basically, we've got a couple different conditions we're going to send. As soon as 15 goes high, that's the third button. We're going to freak out only. We're not going to do any go subs. We're just going to sit still and sound the speaker. If nothing is pushed, 0, 0, 0, the BoeBot's going to be rolling forwards. If both buttons are pushed, that's a 1 and a 1, then the BoeBot's going to roll backwards. And then if I've got just the left button pushed, it's going to go left. Remember, 0 is the right, 1 is the left. And if the right one's pushed, the BoeBot's going to go right. Standard subroutines down here. That's all you need. Alright, take a look at the push-button controlled BoeBots. On the left is the roller, that's the one that's going to stay on the ground. On the right is my driver, that's the one I'm going to hold. So the wiring on the, well, this one is fairly simple. VDD coming into the 3 push buttons. On the other side of the push buttons is the 3 wires that go out to the other BoeBot. It's this one that gets a little convoluted here. I've got 220s at the pins 0, 1, and 15. I've got 10Ks going back to VSS. And then the signal from the push button has to come in to both the 10K and the 220. The 220 protects the pin on the microcontroller, and then the 10K is the trickle down, the drop down resistor back to ground, and then the ground signal comes from both devices. So in this case, that's going to be neutral. That's going to stop the wheels from moving. Right now, the BoeBot's going to be rolling forwards, and then these are going to be left and right, and then backwards. So let's take a look. And that's it.